The universe just changed. A tiny speck of light, barely a pixel in a deep field image, has rewritten the story of everything we thought we knew about the beginning of time. This isn't just the most distant galaxy we've ever discovered. It's something else entirely. It's ancient, powerful, and impossibly complex. Its name? MOM-Z14. Today, we're venturing 13.5 billion years into the past to witness the birth of a galaxy that shouldn't exist, and to uncover a cosmic paradox that's forcing scientists to rethink the very nature of reality. Imagine staring at a field of stars so deep, so distant, that every dot of light is a time machine, each pixel a ghost from a forgotten age. And then, one faint red speck appears. To the naked eye, it's meaningless, insignificant. But to scientists, that pixel was a whisper from the dawn of time. A signal that had traveled 13.5 billion years across an expanding, cooling, darkening cosmos just to reach us. That tiny red smudge is MOM-Z14, and it shattered everything. Before now, the title of most distant galaxy belonged to JADES GS-Z14-0, discovered by the James Webb Space Telescope with a redshift of 14.32. It was a marvel, our first glimpse of a galaxy that existed when the universe was still in its infancy. But Webb's revolutionary infrared vision, with its 6.5-meter mirror and sensors finely tuned to detect the faintest, most stretched out light from the earliest structures in the universe, wasn't finished breaking records. Webb wasn't just a successor to Hubble, it was a revolution. And one of its most cosmic triumphs was spotting MOM-Z14, a galaxy with a redshift of 14.44. Now, redshift is more than just a number. It's how astronomers measure time across cosmic distances. The higher the redshift, the further away a galaxy is. But more importantly, the older the light. A redshift of 14.44 means that what we're seeing isn't just old, it's ancient. We're looking at a galaxy as it was just 280 million years after the Big Bang. Let that sink in. The entire universe was only 2% of its current age. To call this a milestone would be an understatement. This isn't just about breaking records. It's about pulling back the curtain on the universe's origin story. And what lies behind that curtain isn't simple, isn't quiet, isn't what we expected. MOM-Z14 isn't just far away. It's wrong, in the most exciting way possible. It's too small, too bright, too chemically rich, and somehow it formed too fast. This isn't just a galaxy, it's a cosmic contradiction, and it's forcing us to ask the unthinkable. Have we misunderstood how everything began? At first glance, MOM-Z14 looks like a mistake. It's so small, you'd almost dismiss it. A compact galaxy, a mere spark compared to the 100,000 light-year span of our Milky Way. In cosmic terms, it's the size of a teardrop in an ocean. And yet, it burns like a furnace. Galaxies this early in the universe are expected to be dim, disorganized, and slow to form stars. But MOM-Z14 defies all of that. This galaxy is a blazing forge, pumping out newborn stars at a pace that stunned astronomers. It's not quietly evolving, it's exploding into being. The light from this tiny object is so intense, so luminous, that scientists initially thought it might be a mistake in the data. But multiple observations confirmed it. MOM-Z14 is real, and it's alive with activity. But how? How can something so small, so young, shine with such ferocity? Let's put this in perspective. The early universe, just a few 100 million years old, was still in cosmic darkness. Hydrogen gas choked the light. Stars were only just beginning to ignite, and galaxies were supposed to be fragile, flickering embers. But MOM-Z14 is no ember. It's a raging star factory, forming stars 10 to 20 times faster than expected for a galaxy its size and age. This level of star formation generates not only extreme brightness, it creates shock waves, magnetic fields, and radiation that should rip a young galaxy apart, unless something is holding it together. And that raises a bigger question. What's fueling this fire? Is it the density of its primordial gas? Is it gravitational collapse happening at breakneck speed? Or is there some deeper mechanism, something we've missed entirely, powering this early burst of creation? The truth is, we don't know. MOMZ-14 is doing everything galaxies aren't supposed to do this early in time. It's like discovering a fully built city in a time when we thought humans still lived in caves. And just when scientists thought they were beginning to understand the rhythm of the early cosmos, this tiny galaxy arrives like a drumbeat out of time. But MOMZ-14 wasn't finished surprising us. Because the next thing scientists looked for, the chemical signatures that tell us about its stellar history, revealed something completely unexpected. In the heart of almost every galaxy we've ever studied lies a complex ecosystem of stars, gas, and dust. These components work together in a cosmic dance that takes billions of years to choreograph. Young galaxies should be chemically simple, filled mostly with hydrogen and helium from the Big Bang. Heavy elements like carbon, nitrogen, and oxygen take time to build up, created in the nuclear furnaces of massive stars and spread through supernova explosions. So naturally, astronomers expected MOMZ-14 to be chemically primitive. After all, this galaxy formed when the universe was barely out of its infancy. But when scientists focused the Webb telescope on its stellar light and analyzed its chemical composition, they found something that shouldn't be there. Not just traces of heavy elements, but significant amounts, particularly nitrogen. That's not just unusual, it's deeply puzzling. It's like discovering a master chef's kitchen in a time when we thought people had just learned to make fire. Somehow, MOMZ-14 had already experienced multiple generations of stellar evolution in an impossibly short time. This forces us to confront an uncomfortable possibility. Maybe stellar evolution happened much faster in the early universe than we thought. Maybe the conditions were so extreme that stars lived, died, and enriched their surroundings in cosmic fast-forward. MOMZ-14 isn't just breaking our rules, it's rewriting the instruction manual for how cosmic chemistry evolves. Just when scientists thought MOMZ-14 had given up all its secrets, Webb revealed something they never expected. Using its powerful infrared spectrometer, Webb split the ancient starlight from MOMZ-14 into its component wavelengths, essentially decoding its chemical DNA. And there it was. A high nitrogen to carbon ratio, not a trace, a significant abundance. To most people, nitrogen doesn't sound like a big deal. But to astronomers, it's shocking, because nitrogen isn't made in the Big Bang. It's made inside stars, stars that have lived, aged, and died, exploding as supernovae, spreading their ashes across the galaxy. But here's what makes MOMZ-14's nitrogen abundance so puzzling. The galaxy also shows a high nitrogen to oxygen ratio. This specific chemical signature tells a story of rapid stellar evolution, of massive stars burning through their lives in fast forward, enriching the galaxy with heavy elements in record time. In other words, MOMZ-14 isn't just a first-generation galaxy, it's already chemically evolved, already enriched by the remains of stars that came before. But how? This galaxy formed just 280 million years after the Big Bang. That's barely enough time for one generation of massive stars, let alone the complex chemical evolution we're seeing. The nitrogen tells a story of cosmic recycling, of birth, death, and rebirth, all playing out in fast forward. It's as if the universe was in a hurry, pushing through billions of years of stellar evolution in a cosmic blink. MOMZ-14 isn't just ancient, it's experienced, and that experience shouldn't exist this early. If MOMZ-14 were a lone anomaly, we might have chalked it up as a fluke, an outlier, strange but isolated, but it's not. The Webb telescope is spotting more of these early, ultra-bright galaxies, each one challenging our expectations about the early universe. Tiny, bright, chemically advanced, everywhere. And that's terrifying, because our models, our best guesses at how the universe evolved, say galaxies like these should be rare. They should form slowly, grow gradually, and remain chemically simple for hundreds of millions of years. But MOMZ-14 and its mysterious siblings are challenging all of that. They're telling us the early universe wasn't a slow simmer. It was a cosmic pressure cooker where galaxies formed faster, brighter, and with more complexity than we've ever imagined. So what's going on? Are we missing something fundamental? Did we underestimate how fast gas can collapse under gravity? Are we wrong about how quickly stars can evolve? Or is there a deeper flaw in our understanding of time, space, and cosmic history? MOMSI 14 isn't an outlier anymore. It's part of a pattern, and patterns demand explanation. The models aren't broken, but they might be incomplete. The universe just changed. And somewhere out there, in the furthest reaches of observable space, more ancient galaxies are waiting to be discovered, each one a time capsule from the universe's most mysterious era, each one ready to challenge everything we think we understand about existence itself. We're only getting started.